Okay, so let's talk about Gauss-Jordan elimination. I'm going to highlight some things as we read through this. If we put the augmented matrix of a linear system in reduced row epsilon form, then we don't need to back substitute to solve the system. To put a matrix in reduced row epsilon form, we use the following steps. Use the elementary row operations to put the matrix into row epsilon form. Obtain zeros above each leading entry. Remember, the leading entry should be 1 by adding multiples of the row containing that entry to the rows above it. Begin with the last leading entry and work up. Using the reduced row epsilon form to solve a system is called Gauss-Jordan elimination. So when you see Gauss-Jordan elimination, that means you're going to do reduced row epsilon form. If you remember in the notes today or yesterday, we talked about how the leading entry should be 1 for every single one, reading from left to right. The values below those leading entries should be 0. With reduced row epsilon, the values above those leading entries should also be 0. So we're going to look at the previous example from doing row echelon form because we got all the way down here to be row echelon form. But remember, with reduced row epsilon form or Gauss-Jordan elimination, we're going to apply that to the matrix here, which means we want everything above those leading entries to be 0. Notice your leading entries are in green. So all of those are 1, but we want everything above them to be 0, just like everything below them were 0. So the first step I'm going to go ahead and take is I'm going to try to start by working backwards because that's what they told me to do in my steps. So working backwards from the one that's closest to the last leading term, which would be 4. So if I'm going to start with 4, I'm going to multiply -4 by row 3. And I'm going to add that to row 2 to get my row 2. By doing that, I should get 0 for 4. So you can do the math behind that. So my row 1 doesn't change. I have 1, 2, -1, 1. My row 2 now becomes 0, 1, 0, 1. Row 3 does not change, so it's 0, 0, 1, -2. I'm going to go ahead and highlight the values in yellow I need to change to 0. And remember that those in green are my leading entries, which are fine at being 1. You don't want to change those at any point. You want to make sure those stay the same. So now again, I'm going to work to the next portion, which is -1, working my way upwards. So I want to go ahead and make -1, 0. So by doing that, I'm going to add row 1 to row 3, and that's going to give me row 1 to be 0 where I need it to be. So if you do the math behind all of that, you'd get row 1 to be 1, 2, 0, -1. Row 2 stays the same as 0, 1, 0, 1. Row 3 stays the same as 0, 0, 1, -2. So again, I'm going to highlight those entries. My entries are 1. And I'm also going to highlight the value that I want to make 0. So my last portion I need to work with is the value of 2. I want to make 2 0. So I'm going to go ahead and multiply -2 by R2, so row 2. I'm going to add that to row 1, and that will give me what I need for row 1. So if you do that, you'll get row 1 to become 1, 0, 0, -3. And row 2 stays the same as 0, 1, 0, 1. Row 3 stays the same as 0, 0, 1, -2. So if I look here, everything that I needed to be 0 is complete. So this value up here is 0, and these values down here are 0. And then my leading entries are all 1. So now I have put this matrix in reduced row echelon form, or we call it Gauss-Jordan elimination. If we flip back to some of the information that we read about Gauss-Jordan elimination, it tells me here once it's reduced row echelon form, then we don't need to back substitute to solve the system. So with solving this system, we don't have to do backward substitution. Notice here that you have ones in each spot to represent the variable you need. So the first column is x, so you get x equals -3. The second column or second row talks about y equaling 1. And the next row tells me that my value is z equals -2. So that tells me that my solution for this entire linear equations is going to be -3, 1, -2. So understanding that this is the notation for Gauss's Jordan elimination. So if they ask you to put it in Gauss-Jordan elimination, that means that you're doing reduced row echelon. You want zeros at the top and zeros at the bottom. If they ask you to put something in reduced row echelon form, they're telling you that you want your leading entries to be 1, but you also want the values below those to be 0. So as you work on the worksheet, I want you to make sure you read through everything looking for the reduced row echelon form as well as Gauss-Jordan elimination and apply those rules. If you have any questions, just let me know. See you guys on Friday.